product which Microsoft Azure is providing you on a high level, very high level, and firewall is one of them. So before we understand Microsoft offering in general, you should know what the firewall is. So firewall is a network security system designed to monitor and control incoming and outgoing traffic based on predefined security rules. So that's what you can do with the help of firewall. Key points: acts as a barrier. It separates your trusted internal network from untrusted external network. So firewall, as I told you, firewall considers your internal network as a trusted network and external public network as an untrusted network. By default, it allows everything going out from your trusted network to the internet, and it blocks everything coming in to your network from the untrusted network or the public network. So traffic filtering, it is inspects traffic and decides whether to allow or block it based on criteria like IP address, port, and or the protocol. So nowadays we are having firewall doing more than this. What you're seeing here in the traffic filtering, it does not just we have a new product coming in the market called network next generation firewalls, which does not just control traffic based on the IP address, port, and the protocol. It does more than that. It can also have the application filtering. It can understand the application. It can filter the traffic based on the application as well. So the firewall controls the flow of traffic between the two and blocks dangerous stuff from the outside, untrusted, while allowing safe traffic from the trusted inside trusted network. So that's the firewall. We'll see how it is deployed in Azure network. Right. So then, yeah. So that was just about what the firewall is. First of all, it can be a hardware appliance. It can be a software application which you can install on a server and make the server as a firewall. And now here, Azure Firewall in Microsoft Azure Cloud. Azure Firewall is a fully managed cloud-based firewall. So it's a managed service. It's basically the product is available on Azure platform. We can use that and deploy it in our environment in order to achieve the same features of the firewall. What it does in the on-prem scenario, protecting the traffic from two different networks or multiple networks. So the key points about the Azure firewall. This stands true for all the firewalls these days. It is a stateful firewall. That means it can track the state of active connections and make intelligent decisions. So earlier in the olden days, we used to have stateful and stateless firewalls as well. So we don't need to discuss about the stateless firewalls anymore, because now all the firewalls for firewall technologies, they come with stateful firewall. What does it mean? That means it maintains and tracks each connection which is initiated from either from internal network to external network, trusted to untrusted, or untrusted to trusted network. It keeps track of every connection and the state of it. Fully managed, no need for manual updates or infrastructure management. So if it is a firewall which you deploy on-prem, like you manage and maintain the servers, regularly you have to install the updates and the patches on the operating system, and the server you have to keep keep it up to date. Similarly, the firewall, if you deploy the firewall technology as a hardware appliance, you will still have to manage that firewall. You will have to update it regularly based on the updates released from the vendor. So this part is taken care completely by Microsoft, because this is the managed service, the platform as a service product. So Microsoft manages the firewalls in the backend. We just configure and utilize it in our Azure environment. Supports traffic filtering, can block or allow traffic based on IP address, ports, and protocol, and more. So these are the basic. This is the basic functionality of every firewall. It can log the traffic based on the IP address stored in the protocol. But now, as I mentioned, nowadays the firewalls are coming with more functionalities. Application layer controls also are embedded in the firewalls. Application rules can filter traffic at the application level. Threat intelligence integrates with threat feeds to detect and block known malicious IPs. What are the threat? What does it mean? Threat intelligence. The firewall will continuously get the updates from if it is a vendor-based firewall. Every vendor has their own update mechanism, update cloud, where they will frequently update and publish the intelligence about the bad IPs. So mainly about the bad IPs and the threat actors. So the threat intelligence is like an update mechanism on the firewall, which it keeps downloading the data from uh, integrates with threat feeds through the threat feeds to detect and block known malicious IPs. So the public IPs are being monitored regularly, and if any public IP is seen behaving abnormal, if there's a traffic, if there's malicious traffic coming in from specific IP, those IPs are blacklisted, and then those can be blocked automatically with the help of threat feeds on the firewalls. And on Azure, you get two variants of the firewall. When you're deploying the firewall, you can either deploy a basic firewall or the premium firewall. The difference is you can see here why you're deploying the firewall. With the help of firewall, you can protect your VNets, the traffic going in and coming out from the VNets. Even on-prem network, if you have the site-to-site connectivity, you can control the traffic flow. So it supports L3, L7 connectivity policies and Microsoft Threat Intelligence known malicious IPs and affiliates. So this integrates automatically with the Microsoft Threat Intelligence because this is Azure Firewall. So Microsoft maintains a huge database of threat intelligence, and your firewall can automatically fetch that information and block the connections based on that threat feeds. Threat intel, NAT, network and application traffic filtering rules allow inbound or outbound access. So firewalls also does the NATing. It does network address translation. So you also have Premier Firewall. Now, with the Premier Firewall, you have more features like TLS inspection. That means it can decrypt the traffic. If there's any encrypted traffic, it can decrypt and see if there's anything malicious going on under the encrypted tunnel. It also has IDPS, that means intrusion detection and prevention system. So it looks for known, anomalies on the network traffic, and it can take action based on that. It can also do the URL filtering. That means you can allow the access to specific websites or the categories of websites to the users who are there on the virtual network. Web categories, yes, it categorizes the URLs based on web categories. So these are the functionalities which Azure Firewall can provide you for the Azure network. Then you have something called Web Application Firewall. What is the difference between the firewall and the Web Application Firewall? Firewalls deal with mostly layer 3 and layer 4 traffic with this add-on functionalities nowadays which are coming up with the firewalls. And Web Application Firewall is purely about handling the application traffic. It looks at the application layer 7. That means any attacks which are happening on the application level, it can understand. And these are some of the famous attacks: SQL injection attacks, accesses, browse site scripting attacks. Right? This happens on the application level. So the WAF can understand these different kind of attacks which a normal firewall cannot understand. So you can see that the web application firewall is either deployed with the front door. This icon represents the front door here, or it can be activated on application gateway of Microsoft. So load balancer, what we have discussed, application gateway load balancer and the front door load balancer. So you can see that there's no independent WAF product available from Microsoft. It will be deployed as part of the application gateway, or it can be deployed as as part of the front door service. So prevents attacks in application code. So it literally looks at the application data and the code which you are publishing through your WAF. Protects your web apps from threats like SQL injection, cross-site scripting, and other common web attacks without changing your code. Centrally manages security for application. One place to apply and manage security rules for all your web applications instead of configuring each app separately. Deploy WAF with application gateway, front door, or CDN. Even with CDN, you can deploy the WAF. Right. So that was about the WAF, web application firewall. Now we have some information about the DOS and the DDoS attacks. So in order to understand what is DDoS attack, you should understand what is DOS. So DOS is basically the DOS stands for denial of service attack. And what happens in this attack? A DOS attack is when someone tries to overwhelm a server, website, or network by flooding it with too much traffic or request. Right? This makes the target system slow down or completely crash. So legitimate users cannot access it. So this is the purpose of the attack, DOS attack. And DDoS attack. Now, this DOS attack is multiplied with DDoS attack. So what happens is it's a distributed denial of service attack. So DOS and DDoS. Distributed means in the DOS, the attack is happening from one particular source in the internet, and it tries to bring down your service. In DDoS, the attack will come from different sources. That's why it is called distributed. A DDoS attack is like a DOS attack, but bigger and more dangerous. It happens when many computers, often part of a botnet, send huge amounts of traffic to the target at the same time. This makes it even harder for the server to defend itself because the attack comes from multiple sources. We have some more explanation here. Simple DOS attack. Imagine you have a small website. You're publishing a website. We have seen how we build and deploy the websites, right? We have, for example, we have built one website, abc.com, and that website is only a size for 1,000 users. It can handle only the traffic for 1,000 users. That means it can receive 1,000 concurrent connections and it can process it easily because the size of the VM or the application is based on that. So a hacker decides to overload the website by sending thousands of requests to it in a very short period. The website cannot handle all the requests and crashes. So if your server receives instead of 1,000 requests at the concurrent connection at the and at one given point of time, if it receives double the traffic, it will not be able to cope up with it. It cannot because it doesn't have the resources to process those many number of connections at the same time. So very simple example, a hacker repeatedly processes refresh on the website so many times that the server runs out of resources and stops working. So you keep hitting the refresh button. Every refresh on the website, it generates a new connection request to the web server, and it can bring down the whole website. So here is a simple one-line explanation for the DOS and DDoS attack. DOS is one attacker tries to make a system unavailable. DDoS, many attackers often using compromised computers try to make the system unavailable. You must have heard the DDoS attacks, many DDoS attacks which has brought down the services, global services many times. So this is a sample diagram you can see here. So what is a bot? A bot can be anything. If you see here, a bot can be an infected PC, your PC or my PC if it is not properly protected. A malware can be run on that, and that malware can initiate the connection to the web server, particular web server. So what is the purpose of DDoS attack? Right, a DDoS attack is basically performed to exhaust your resources and make your service unavailable. That's the motive of the DDoS attack. A DDoS attack overwhelms an application by flooding it with massive traffic. Azure DDoS protection, we have a DDoS protection. We'll look at that, what it does. Attackers use a botnet That means it can be an infected PC, IoT, or servers. IoT is what? Internet of Things. Now every home appliance is coming with the intelligence, right? Uh, which through which it can connect to the internet and you can manage those devices. So these home appliances can also be compromised. A malware can infect those devices, and those can also act as bots for the hacker, right? All bots send traffic at the same time. So all this which you see, it can be a PC, it can be a IoT device, it can be a server which is infected, and it keeps sending the HTTP get flood attack to the server. They keep trying accessing the server. The goal is the DDoS attack goal is not to hack. Basically, this is not mainly for hacking, but to exhaust bandwidth or resources of the server. So legitimate users cannot reach the app. So if the server is overwhelmed with millions of hits, eventually it might crash, and the actual legitimate users cannot access the service. So this is what about the DDoS attack is. Azure has two offerings. Azure offers you by default there's a DDoS basic DDoS protection activated on Azure networks. Whatever you deploy on Azure, the basic protection. You also have options in protecting your uh, whole network. DDoS IP protection. You can purchase this service per IP, per public IP, or the whole network protection. So that actually covers your 100 protected IP sensors, DDoS network protection. So IP-based protection or network-based protection. So Azure DDoS protection is a managed service that protects your Azure resources from distributed denial of service attacks, right? So that's what the DDoS protection does. We have seen Azure Bastion already many times actually, and you should be very much familiar with this, what the Azure Bastion is and how it helps us in accessing the virtual machines which we deploy. I'm not going to repeat this again. Just in time access, I have just briefly explained yesterday what it can do. Basically, it grants you access to your virtual machine temporarily based on the specific time, date and time. So that's the functionality you get with the JIT. Network Watcher is a built-in service again with Azure, through which you can perform all these activities. You can do the monitoring of traffic, connection monitor and topology. You can see the topology as well. Network diagnostic. It has diagnostic tools for troubleshooting your connections, IP flow, next hop, packet capture. You can do the packet capture and see if there's any issue with the connectivity. And it shows you all the basically it is a tool to which gives you all these functionalities. And this IP flow verified diagnostic is part of this. You can see it's part of the network watcher. You can see the IP flow for a specific connection. If there's any connection failing, you can verify if the traffic is allowed or denied by a specific NSG rule or the firewall or whatever it is. So next hop diagnostic, you can track actually see the traffic flow from one hop to the other hop. That means if you have multiple hops deployed in your network, a hop is a network component in between one network to the other network. So you can visualize the network topology. You can see your network topology in Azure. And let's see if you have the network voucher available, how we can access that on Azure platform. What happened? You can also see that. I'll show you that as a demo. So let's look at the VPN. That's the last topic we have, I guess. Three more slides. What is the VPN technology? It's very commonly used these days, uh, and especially when you're in UAE, you must have used one or the other VPN software, the solution or the applications mainly for calling your home countries, right? So that's the personal level of VPN usage, what we have seen. In the corporates, in the organizations, VPN is still widely used, right? With VPN technology uses encryption and secure tunneling to protect your data and keep your internet activity private. So VPN technology creates a secure encrypted connection over the internet to protect your data. It does encryption and it does tunneling. It uses tunneling protocols for hiding the traffic, and there is authentication mechanism as well. In some simple terms, a VPN connects your device to a remote server. It can be a remote server or it can be a site-to-site VPN. We'll see in the next slides. Encrypting your internet traffic so no one can see or tamper with it. Right? That's the purpose of the VPN. Now there are different VPN protocols available. Uh, in uh, in the corporate world, in the organizations, VPNs are used in two different ways. One is the site-to-site VPN, wherein it uses IPsec as a protocol for site-to-site connectivity. So you can see in the diagram here, in the down, we are connecting our on-prem setup with the Azure cloud with the help of VPN tunnel. So it's an IPsec IKE 2 site-to-site tunnel. So these are the two protocols, IPsec and the Internet Key Exchange version IKE 2. It uses this the combination of these protocols for establishing this tunnel between your on-prem network and the Azure cloud. So this is still widely used between the businesses side to side for side to side connectivity. It can also be in if you're not using the cloud, it can be your site office, your branch office connecting to your on-prem, connecting to your headquarters for accessing and using the data of the application from the central site. So in this scenario, what will happen is how do you establish the site-to-site VPN? You need something on the Azure side, you need the VPN gateway, and on-prem side, you need a device which can do the VPN tunneling. Mostly the firewalls support the VPN technology. So with the help of firewall, you can also do the IPsec connectivity, or there are some products which are built for, there are purpose-built products which are used only for the VPN connectivity. They can deploy a VPN, I just call a VPN gateway, like you see here in the Azure network. So you can deploy a dedicated VPN solution as well. And there is a point-to-site VPN, and these are different protocols which are used for point-to-site connectivity. That's mainly the client VPN client access to the servers or the headquarters network. So in this scenario, we are looking at providing the site-to-site connectivity, the site-to-site VPN connectivity between Azure cloud and your on-prem network setup infrastructure, or we can also do site point-to-site connectivity from the client machines to the Azure network. We can make use of VPN connection. So this is the mechanism we can access your servers. So, when we were discussing the options of accessing the Azure virtual network or Azure virtual machines and managing it, one way was directly having the public IP assigned to the VMs in order to manage it over the internet. The second way was Bastion host. We can deploy the Bastion host. The third option was if you have the setup like this on-prem setup, and if you are part of this network, we can manage these virtual machines over the site-to-site connectivity. And if you don't have that, you can make use of point-to-site VPN technology, and you as an administrator, without exposing your virtual machines to the internet, through VPN channel, VPN connectivity, you can manage your Azure resources. So that's the point-to-site connectivity, right? So now the Azure provides you a product called VPN Gateway. which you can deploy, which securely connects your on-premises network to your Azure virtual network using encrypted traffic. There are different configurations available for VPN gateway. You can deploy the VPN gateway in site-to-site mode or point-to-site. Or you can also use the VPN gateway to connect VNet to VNet. Why would we need to use VPN for the VNet to VNet connectivity? We have, what is the other option we have for connecting one virtual network to the other virtual network? Is there any other option we have? Khaja, are you still with me? Are you guys still with me?
Yeah.
What is the technology we have in Azure which is readily available uh, for connecting VNet to VNet, virtual network to virtual network?
So VNet peering.
Exactly. That's the right answer. Sudhini has answered that. We have VNet pairing, right? So when if you have two different virtual networks, we can do a VNet pairing. We don't really need to use the VPN gateway for that purpose. But why it is saying here we can utilize a VPN gateway? It can be different between different organizations. So you don't want to do the VNet pairing. You want to have secure connectivity between two different regions of two different organization VNets. So you can make use of VPN gateway there as well. Because in here you'll have more control on the traffic flow and you can do more restrictions on the traffic. So here we can, this is the VPN gateway product which is available. We'll be seeing this in the lab, how we can deploy this. And then we have Azure Express Route. This is the second mechanism we can use for connecting our on-premises network to the Azure cloud. But we can't really see that in the labs because that requires connectivity from your ISP provided to you on-prem connect to the Azure cloud. But you should just be aware of it that this is the option. There are two options available for connecting your on-prem network to the Azure network. Either use the IPsec tunnel VPN connectivity or use the Azure Express route. Okay. Here we have some technology comparison slide, which tells you the services, the technologies which we have discussed today. Load balancer, L4, how does it compare with the products which are deployed on-prem, right? So if you look at the load balancer product, which we have seen here, Azure Load Balancer, there is a very common famous product which is used in on-prem scenarios. It actually comes as a hardware appliance. F5 Big IP. It is called F5 Big IP LTM, Local Traffic Manager. So F5 is a company which builds load balancers, and their load balancers also come with web application firewall. So F5 is one of the product which is very commonly used, famous for on-prem solution for the similar technology. There's a product from Citrix as well. If you have heard